Response time. As a general rule, for response time, if it is less than 0.1 seconds, then no special indicators are needed. However, after about 1 second users tend to lose track of what is going on. Indeed, 10 seconds is roughly the maximum duration a user will stay focused on one action. For longer delays than this, a percentage done progress bar should be used to indicate what the system is up to, e.g. whilst indexing a hard drive. Macoso shows the following dialog, which includes a progress bar, indication of what it is currently doing, and expected time remaining to complete the activity. 2.2 Match between system and real world. A classic example of this heuristic being flouted is the way in which disks are ejected from Macoso-based computers. Usually, the trash can icon is used to delete files, that is to throw them away, and the save icon is used to save data, as shown in the illustration. 2.3 User control and freedom. The user shouldn't be forced down fixed paths, that is undo and redo. For example, wizards as illustrated below, users are forced down fixed paths to complete tasks. Note the back and next buttons which dictate the sequence. Note also the cancel and finish buttons which provide some level of user freedom. This is okay for uncommon tasks such as configuring a modem, but not good for frequent tasks which should have a different style of interaction. 2.4 Consistency and standards, as well as the consistency within the system, as discussed in the previous set of heuristics. We also need to consider consistency between applications. E.g. in Macoso there are consistent menu names and shortcuts between different applications. Note also in the above illustration that all the words are consistent in terms of their typography, which letters are capitalized and which are not. Mixing capitals and lowercase words inconsistently may cause confusion in users, but would probably not be spotted during their user observations discussed earlier in their unit. 2.5 Error prevention. See original heuristic 1.9. 2.6 Recognition rather than recall. Generally the same as original heuristic 1.3. Minimize memory load. 2.7 Flexibility and efficiency of use. Does the system support shortcuts for experts, illustrated by the shortcuts provided in the following Macoso menu, and is it possible to tailor the system? E.g. providing support for macros to automate frequent tasks. 2.8 Aesthetic and minimalist design. Does the system present irrelevant information? E.g. the following Macoso illustrates an attempt to hide information from their user when it is not relevant. The first dialog below shows the minimal information needed, but can be expanded to the second interface if the details need to be viewed and edited. 2.9 Help users recognize and recover from errors. Are the error messages in plain language? Do they precisely indicate the problem and, importantly, constructively suggest a solution? E.g. in the past, command line-based systems have been known to give errors such as the following. This tells the user the problem, but the solution is hardly constructive. 2.10 Help and documentation. Does it list concrete steps to carry out? E.g. Macoso provides constructive help on setting up the modem for your computer. As illustrated below, there is a list of concrete steps which relate to the task at hand and are not too long. In addition, there is some indication on the actual interface in question and of what operations need to be carried out, solely reinforcing the help indicated by the red ellipse on the modem control panel below. Cognitive walkthrough. Compared to heuristic evaluation, cognitive walkthroughs are less prescriptive in terms of the kinds of problems that should be looked for in the evaluation. The emphasis is more on learnability, and the basic approach is that the evaluators step through a scenario using the system, and at each step attempt to decide whether users would have trouble in moving to the next, hence the term walkthrough. The first stage of a cognitive walkthrough is to define the inputs to the evaluation, what things we are going to consider in the evaluation. The first input we need to consider is the users. In particular, who are the typical users going to be, and what experience and knowledge can we expect them to have? Once we have defined who our potential users are, we consider what tasks they will be performing with the system. The descriptions of the tasks to be supported often come from the task analysis stage. See Unit 8. Once we have understood the tasks, we need to determine the action sequences of the tasks. That is, we need to work out what each step involved in completing the tasks are, and what sequence they are in. This description of the task action sequence will constitute the steps that are walked through by evaluators later. Finally, we need a description of the system itself, in particular its user interfaces. This may be an implementation of the interface, a prototype, or some mock-up drawn on paper, just so long as the task can be stepped through using the description given. Now that our inputs have been defined and our analyst selected, we can proceed with the evaluation. Each analyst steps through the sequence of task actions that are necessary to complete the task. At each step, the following questions are asked. Would a user try to achieve the right effect? Would a user notice that the correct action is available? Would a user associate the action with the desired effect? If correct action performed, would progress be apparent? For each of these questions, we need to note down not only the answers, but also additional important information, including the knowledge requirements of the user, our assumptions about the user, and possible design changes. This extra information can provide important insights for redesign of the system. Finally, once we have stepped through the task actions and noted down all the problems and extra information, we need to work out how this feeds into redesign of the system. Considering the first question above first, supposing the user fails to try to get the right effect, i.e. perform an action with a user interface, we need to consider what could be done in the redesign to address that problem. Two possible solutions are simply to remove that action from the task. Maybe our task analysis had a mistake in it, or to prompt the user for the action, so making it clear that they are supposed to do something at that point. Alternatively, some other part of the interface could be changed, so that the user knows that they should try to perform an action. Moving on to the second question, whether the user notices that the correct action is available. We need to consider what to do in terms of redesign if the user does not notice that the correct action is available. One possible solution is to make the action more obvious in the interface. Maybe it is hidden in some submenu. Similarly, failing the third question would mean that the user did not know which action is the correct one. Finally, supposing progress is not apparent when a correct action is performed. The fourth question. This means that the user has no way of knowing if things are going well with their attempt to complete their task. A redesign solution would be to give some feedback to the user, maybe at least an hourglass to indicate that some action is being performed. Better still, the interface can indicate that progress is being made, and additionally indicate what it is doing to contribute to this progress. See the example of Heuristic 2.1 in the Heuristic Evaluation section. Model-based evaluation. So far, we have considered evaluation techniques in which someone, a user, or an evaluator actually uses the interface, or some mock-up of it. Another approach to evaluation covered in this section is the use of models. See Unit 7 for a discussion of modeling of the interface and understandings of human cognition to evaluate interfaces without actually using them. Perception-based evaluation. Whilst developing ICS, May, Scott, and Barnard 1995 developed a method of analyzing user interfaces, which takes into account human perception. Consider the following scene. In this image we perceive a table in a room whose door is open. Outside, we see a tree and a hill. Inside, on the table, we see a vase of flowers and a piece of paper. The key is that we perceive that this is what the collection of lines indicates, that the lines represent these objects. So, when looking at an image such as the one below, or a user interface, we apply psychological processes to interpret the image as a set of objects. Importantly, this perception of objects is focused. That is, we look at particular parts of an image and concentrate on them. For example, we might look at the table, and then the objects that are on it, the vase with flowers, and the paper, or we might look at the door, and the objects we can see through it, the tree, and the hill. This view of perception assumes that our perception works hierarchically. The figure below illustrates a hierarchy for the objects in the figure above referred to as an object structure diagram. Using this hierarchical structure, we can see that what we perceived is constrained by the level we are on. The changes in focus of perception, as we view different parts of the scene, are referred to as transitions. Below is a transition diagram of someone changing from focusing on the vase containing flowers on the table to focusing on the tree outside. Transition diagrams show change in focus as a sequence of steps from top to bottom of a diagram. In the diagrams, the object currently focused on is outlined in black in the first step. Below that is the vase. To the right of the focus object, and within the same box, those objects on the same level of the hierarchy. In the first step below, the only sibling of the vase is the paper. To the left of the focus object is the parent of that object, the object that is directly above it in the hierarchy. For the case of the vase, the parent is the table. Finally, to the left of the sibling objects are child objects of the focus object, which in the case of the vase are the flowers. Thus, all possible changes in focus are thus shown on one line, e.g. from the vase the focus could change to its parent to the left in the diagram, the table in this case, a sibling immediately to the right in the box, paper, in this case, or its children. To the right of the box, flowers in this case. So, there are three kinds of movement which need to be represented in the diagram. Movement up the hierarchy to the parent is indicated by E. The first transition, below, is up the hierarchy from the vase to the table. Notice how the focus object changes in the next line, as do the parents, siblings, and children. Movement between siblings in the hierarchy is indicated by, as illustrated in the second transition below, from table to door, both children of the far wall, hence the far wall stays as the parent between steps 2 and 3. Finally, there are movements from parent to children which are indicated by C, as illustrated in the third transition from door down to its child tree. You might be wondering, what on earth this has to do with evaluating user interfaces? Such understandings of perception come into play when we consider the tasks users are to perform and the user interfaces they use to complete their task. GOMS, perception-based evaluation, used an implicit notion of perception developed from psychological understandings of cognition. GOMS contrasts this by using an explicit model of cognitive processes developed from studies of users. GOMS itself stands for Goals, Operators, Methods, and Selection Rules. See Unit 7. The quantitative predictions of execution time produced by GOMS can be used to compare designs. As mentioned in the introduction, PRIES identified four main purposes for doing evaluation, which are outlined below. Clearly, the purpose of the evaluation dictates the kind of evaluations that we should perform, and the data we would want to collect. These issues are also outlined below. Engineering towards a target, asking whether the system we have designed is good enough yet. The question we have to ask ourselves here is, what targets are being engineered towards? If it is in terms of user satisfaction, for example, then we might employ a technique such as user studies, where we can get qualitative information about whether the user is satisfied with the system. Comparing designs to identify which designs are best for a given set of tasks. In general, most evaluation approaches can give us some comparative evaluation, but quantitative results are usually the easiest to use for comparisons, e.g. the results produced by user experimentation, some user studies, and GOMS. Understanding the real world, working out how well the design would work in the real world, such as an office or other workplace. Approaches such as GOMS and user experimentation do not give us information about how the system will fit into the real world. Other approaches such as user studies, where the system could actually be evaluated in the real-world site, would be more appropriate for such questions. Checking conformance to a standard, whether the system meets standards that have been set. Again, we need to consider what the standards are that we are trying to conform to. If they are that a task should be performed within a specific time limit, then we could use an approach such as GOMS to predict the task completion time. Stage of system development provides us with a much more flexible process, in which potentially time-consuming problems are identified throughout development. The stage at which evaluation is performed will determine which kinds of evaluation techniques are appropriate. At the very beginning of the process, interview and questionnaires are probably the most appropriate, as they can give us plenty of information to inform the design. Once some more rigorous designs have been developed, we might try using GOMS or ICS to compare designs for specific issues such as task completion time or difficulty to learn. If we have more time and effort, more grounded results, i.e. not just predictions, could be obtained from user studies, heuristic evaluation, cognitive walkthrough, and user observation. In some cases involving users very early in the design process may be problematic, as they may be put off by the incomplete nature of designs at that stage. Type of data. As discussed throughout this unit, there are two main kinds of data which can be collected from evaluations: quantitative numerical values such as time or attitude ratings, and qualitative such as opinions. These two types of data provides answers to different kinds of questions, and moreover, are generated by different kinds of evaluation. The key is to select the evaluation technique which produces the kind of data necessary to answer the questions being asked. Click on the button Table to view the table. The table below lists the kinds of data we might expect to be able to get from the different kinds of evaluation we have discussed in this unit. Considerations. Different kinds of evaluation require different time, effort, number of people involved, and equipment. It is important to consider whether a certain kind of techniques is appropriate for the stage of development. We then need to consider how valid the data we have collected is. This refers to whether the data collected is suitable for the purpose of the experiment. If we were to try to use GOMS to predict the time it would take a novice user to complete tasks using a system, we would get invalid results, as GOMS is designed to predict task completion times for expert users, not novices. Our data might be valid, but then we have to ask ourselves whether it is reliable. That is, whether we can expect the same results consistently. Clearly, for model-based evaluation, this depends on the way in which we use the models. Similarly, when performing evaluator-based evaluation such as heuristic evaluation, it depends on how well the evaluators are trained, and whether we have enough to produce reliable results. When users are involved, well-designed experiments should give reliable experiments, whereas user observation tend to give quite unreliable results. We might be concerned with reliability when considering whether the system meets certain standards. Meeting standards needs to be shown by reliable evaluations. Finally, we need to be aware of the biases that we may be introducing into the results of our evaluations. Please identify two main sources of bias: selective data gathering concentrating on certain aspects of the situation, and not taking into consideration others, which may also be important. Manipulation of the evaluation situation, for instance, asking leading questions in interviews rather than letting interviewees formulate their own answers.